We have two bars which are connected as shown. Our goal is to determine the cross-sectional area of each bar so that the bars rupture simultaneously when a load of 13.5 kilonewtons is applied. We will assume that buckling does not occur. When we look at the stress-strain diagram, we see that the maximum stress for compression is equal to 175 MPa. And the maximum stress for tension is 35 MPa. Let's first draw the free body diagram. Suppose that this is the point B. We will have a force P and another force FBC and also another force which will be FAB. And suppose that this angle is alpha, so that this part of the triangle is 1.2 millimeters, as you can see, and this part is 1 meter. So hypotenuse becomes 1.56 meters. And we can say that sine alpha will be equal to 0.77. And similarly, cos alpha will be equal to 0.64. Now we can write the force equations. We know that the sum of forces in the x direction will be 0, and minus FBC minus FAB times sine alpha will be 0. We can write it as similarly, the sum of forces in the y direction will also be 0. And we have minus FAB times cosine alpha minus P in the y direction. Let's substitute the value of cosine alpha. So from this equation, we can say that P will be equal to minus FAB times 0.64. We know that P is equal to 13.5 kilonewtons, so FAB will be equal to minus 21.1 kilonewtons, and it is compression. Since we know AB, we can calculate FBC too. We know that FBC is equal to minus FAB times 0.77, and this will give FBC as 16.24. So this is positive, and we can say that this is tension. So for AB, sigma max will be equal to FAB over the area of AB. And area of AB will be equal to FAB over sigma max. Since FAB is compression, we will use the stress value for compression, which is 175 MPa. We know that FAB is equal to 21.1 kilonewton, and the stress is 175 MPa. So that the area of AB will become 120.6 millimeters square. Similarly, when we do the same for rod BC. Again, sigma max will be equal to FBC this time over the area of BC. Again, we can say that ABC will be equal to FBC over sigma max. Since FBC is tension, this time we will use the maximum stress for tension. So this equation will be 16.24 kilonewtons over 35 MPa. And the area of BC will be 464 millimeters square.